Hello everyone. Today we are going to discuss about session 2 in theory of computation, that is topic finite automata. So in this session we are going to discuss about the finite automata, and that is theory of automation, and what are all the mathematical representations are there in the finite automata. So first we'll see what is theory of automata. Theory of automata is a theoretical branch of computer science and mathematical. It is a study of abstract machines and computational problems that can be solved using these machines. The abstract machine is called the automata. An automaton with finite number of states is called finite automaton. So what is the theory of automata? It is the one of the theoretical branch of the computer science and the mathematical. And in this branch, so we are going to study about some abstract machines. So abstract machines and the computation problems, so that is used to that can be solved using these machines, so which are used in the automata. So that abstract machines will be called as automata, and automata with finite number of states are called finite automata. So introduction to the finite automata. Finite automata is the simplest machine to recognize patterns. So what is this finite automata? I already told you. So the finite automata is an automata with finite states, and it is one of the simplest machine. It is used to recognize the patterns. And so the finite automata or finite state machine is an abstract machine which have five elements or five tuples. It has, so finite automata has five tuples, and it has a set of states and rules for moving from one state to the another state. So when the states, so it has some set of states, so when it has to move from one state to the another state, it has to follow some rules. Some rules are there to move us from one state to the another state, and but it also depends upon the input symbol. So in the examples you'll come to know that. Next, basically it is an abstract model of the digital computer. So this figure shows some essential features of general automata. So here are number of input symbols. So this is the state of the automata, and this is the output. So this is the general feature of automation. So next topic is finite automata. So you already know that finite automata is an abstract model of a digital computer. So which has a finite number of states. And what are all the components are there in the finite automata? So there are five components are there in the finite automata, that is input, output, state of the input, state relation, output relation. These are the five components of the finite automata. So next topic is mathematical representation of the finite automata. So you already know that a finite automata has five tuples. So which are that five tuples? So we have to represent mathematically finite automata like this. So these are the five tuples. So this is capital Q, what is sigma single, Q naught, F, capital F, and this uh, transition symbol. So here what is this Q indicates, where Q is the non-empty finite set of states. So it is how many states, how many set of states that we are using in the what is that machine. So that will be represented by this Q. And so this symbol, it is alphabet symbol. You already know this is alphabet symbol. Alphabet, it is an non-empty set of input symbols. So how many input symbols that we are using in the machine, so that symbols will be represented by this alphabet. Next, Q naught. Q naught, which is belongs to this set of states. So Q naught is the initial state, or Q naught is also called as a start state. And F, next one, F is the set of accepting state or the final state. F is the final state. And so this is transition function. the transition function is equals to the set of states into alphabets that leads to some set of states. That is the transition function. So this is about the mathematical representation of the finite automata. So in the examples you will come to know this. Next one, transition diagram. What is the transition diagram? After we write the mathematical expression for the finite automata, we have to write the transition diagram for that automata. So what is this transition diagram? A transition diagram or a state diagram. It is also called a state diagram, and it is a directed graph which can be constructed as follows. How can we construct a transition diagram? There is a node for each state in Q which represented by circle. So the state of a circle, the state of the each state of a node is represented by circle. See here, this Q1 is a state, and the state of the there is a node for the each state. So that node will be represented by a circle. This is the state. Next one, there is a directed edge from node Q to node P labeled the if transition from Q to A is P. So that is the transition. So this is the arrow mark. So arrow mark, the directed arrow mark is represented in order to show that from one state to another state by using the input symbol, that is transiting. Next one, in the start state, there is a arrow mark with no source. So how can we represent in start state? So we can represent in start state with a circle to the node and arrow mark to that state. So this indicates that this is a start state. And next one, accepting state or the final state are indicated by double circle. So when the state is represented by double circle, that means that is a final state or an accepting state. Next, some notations that are used in the transition diagrams are, look at this. So whatever I explained in these points, so that is diagrammatically represented here. This is the state of an each node. So this arrow mark indicates the transition from one state to the another state. So this indicates the start state. So double circle indicates the final state. So this is about the transition diagram. Next one, transition table. So how can we write the transition table? What is a transition table? Transition table is basically a tabular representation of transition function. It takes two arguments, a set of a state and a symbol. A transition table consists of a state and a symbol, and it returns a state to the next state. A transition table is represented by following things. So what is the transition table represents? The transition table represents columns correspond to the input symbol. So there is a transition table, see like this. So this columns indicates the input symbol. The rows indicates the state. See here, rows indicates the state, and entries corresponding to the next state. The start state is denoted by an arrow with no source. The starting state is denoted by a arrow with no source. So next, the accept state is denoted by a star. So when the state is denoted by a star, that means that is a final state. So this is about the transition table. So what are all the things are there in the transition table? It consists of the table that consists of columns as input symbol, rows has states, and the entries corresponding to the next state. State is denoted by an arrow, accept state is denoted by a star. And so for example, we'll take one example. So this is the example of one finite automata. So consider this one diagram. This is one diagram. So here, how many states are there? So we have three states, that is Q0, Q1 and Q2. So this is a start state. How can we tell that this is a start state? Because it is represented by a arrow. So that's why it is a start state. 0 and 1 are the input symbols. So we have only zeros and ones as the input symbol, and the double circle indicates the final state. So Q2, what is it? Q2 is the final state. So how can we write the transition table for this diagram? So the solution is the transition table of a given finite automata is, so the present state, next state and the next state. So here this is input 0, this is input 1, input symbol 0, input symbol 1, and these are the states. How many states we have here? We have 3 states, Q0, Q1 and Q2. Q0, Q1 and Q2. So this is the start state, this is the final state that we represented by star. And so how many input symbol we have? 0 and 1. So that we have represented here, 0 and 1. The transition from Q0 to 0, this transition from Q0 to 0 is Q1. That's what we written here. The transition from Q0 to 1, the transition from Q0 to 1 is Q2. So that is we have written the transition from Q0 to 1 is Q2. Next, the transition from Q1 to 0, Q1 to 0 is Q0. So that we have written here. The transition from Q1 to 1, the transition from Q1 to 1 is Q2. So that is we have written. Next, the transition from Q2 to 0 is itself, Q2. The transition from Q2 to 1 is self, that is Q2. So that is we have written. So this is how we write the transition table for a given automata. So the explanation for the previous problem is, in the above table, the first column indicates all the current states under column 0, 1, and the next states as shown. The first row of the transition table can be read as, when the current state is Q0 on input 0, the next state will be Q1. On input 1, next state will